In this video, I'll explain Rayleigh's power method to find the dominant eigenvalue or the largest eigenvalue and the corresponding eigenvector of a square matrix. See how to do that. Find the largest eigenvalue and the corresponding eigenvector of this matrix. So first I have to take the initial approximation. I am taking initial approximation as the column vector 1, 1, 1. The other possible options for initial vectors are 1, 0, 0, 0, 1, 0, 0, 0, 1. These are the simplest and easiest vectors to be taken as initial approximation. It is not specified in the question. Now you have to find out a in x naught. So that gives you 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3 into the column vector 1, 1, 1. This is equal to, take the first row and this first column, 6 minus 2 plus 2, that is 6, minus 2 plus 3 minus 1, minus 2 minus 1 minus 3 plus 3, it is 0, 2 minus 1 is 1, plus 3 it is 4. So now from these three values you have to find out the largest. Largest is 6. Always you have to take the largest value common outside. So 6 by 6 it is 1, 0 by 6 0, then 4 by 6 value. 4 by 6 gives you 0.666. So you have to approximate this to 2 digits after decimal point. So I will round it off to 0.67. So this is equal to lambda 1 and x1. This was the initial approximation, the first approximation for the eigenvalue and the eigenvector. Now you have to take this first approximation to find out the next approximation. So that is equal to, a remains same, 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3 into the first approximation is 0.67. So that gives you, this is the first row, first column, multiply 6, this is anyway 0, plus 2 into 0.67. So here I will get 2 into 0.67, which is equal to 1.34. So 6 plus 1.34, that is 7.34. 7.34. Similarly, minus 2 plus 0 and minus 0.67 is like this. Minus 2 plus 3 into 0, 0, minus 0.67. So that gives minus 2.67. Then 2, 0 and 0.67 into 3. 0.6 to 3. 2.01. Here 2 plus minus 1 into 0, it is 0, plus 3 into 0.67 is 2.01. Altogether it gives you 4.01. This is equal to, you have to search for the largest value among these three values, which is 7.34. The largest among these three. Take it outside. 7.34 by 7.341. Next 2.67. 2.67 divided by 7.34, which gives you 0.3637. So you can round it off to 0.36. So with a minus sign here, minus 0.36. Similarly, 4.01, last value is this. So 4.01 divided by 7.34 gives you 0.546. You can round it off to 55. 0.55. So this is the next approximation, lambda 2 and x2 for the corresponding eigenvectors. Now continue this process until you get the close approximation. Sometimes they will specify in the question how many iterations have to be done. Here I am continuing as it is not specified, because there is a huge difference between 6 and 7.34. Okay, and the eigenvector values are also different. Some close approximations you should get. So 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3 into take the previously obtained approximation, that is 1 minus 0.36.55. So this gives you 7.82. Then next value is minus 3.63, then 4.01. Do the calculation as before, like 6 plus minus 2 into minus 0.36 plus 2 into 0.5. When you add up all those after multiplication, you'll get 7.82. Now among these three, 7.82 is the largest. Take it outside. Then you'll get 7.82 by 7.821 minus 3.63 by 7.82. You'll get minus 0.46 after rounding off to 2 digits after decimal point. Then this value 0.51. So this gives you lambda 3 and x3, third approximation. Similarly, you continue like this. A into x3 you take. This is 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3 into this third approximation what you got, which gives you 1 minus 0.46.51 is equal to, which gives you 7.94 minus 3.89, 3.99. Out of these three values, 7.94 is the largest. Take it outside. Then 1. Here minus 3.89 divided by 7.94 is minus 0.49. Then last one is 0.5. This gives you lambda power 4, fourth approximation, x4. So continue again, because there is a difference between 7.8, 7.9 here, and here eigenvalues are also different. Little closer, but still more approximate you have to. Is equal to 6 minus 2, 2 minus 2, 3 minus 1, then 2 minus 1, 3, 2. 1 minus 0.49 and 0.5. Take this vector and multiply here. So this gives you 7.98 minus 3.97 and 3.99. That is equal to, out of these three values, 7.98 is the largest. Get this 1, then this is minus 0.5 and this is 0.5, which is equal to fifth approximation you got. Now you can stop here, or else you can try one more approximation, one more iteration to get the exact approximation. 7.94, 7.98, almost close to 8 it is. You can take dominant eigenvalue as 8, and here there is a almost third entry is same, 0.5, 0.5 repeated, 0.49, it is minus 0.5, you get 1 same, or else try one more. So you will get a 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3. Most of the times 5 iterations are carried out in Rayleigh's power method. So multiply this with the vector 1 minus 0.5 and 0.5. So this is equal to gives you value is 8 minus 4, 4. You get the exact approximation here. When you take 8 common, because that is the largest, 1 minus 0.5 and 0.5. So this is the sixth approximation to carry forward. For the next, you can stop here because almost same eigenvector you got, and 7.9894, which is rounded off to 8, here you got exact value 8. Therefore you can conclude now the largest eigenvalue is 8, and the corresponding eigenvector is the column vector 1 minus 0.5 and 0.5. This initial was 1 1 1. Now this is the eigenvector corresponding to the largest eigenvalue. I hope you understood. Thank you for